Okay, ladies and gentlemen, welcome to our next talk from Sophie Mould. Sophie is a product manager in Mapbox. Mapbox, again, sponsor of today, so thank you very much for that. Many of us will have used the Mapbox libraries and their open source offerings for years and years and years. Tippy Canoe, and I'm a massive fan of that. Sophie's going to talk to us about range anxiety and work that she's been doing in this field. Sounds fantastic to me because as a cyclist I suffer from range anxiety all the time. In my case it's down to my own digestive system, but Sophie's going to talk about electric vehicles and the work that they're doing there around navigation. Thank you, Sophie.
Thank you. Hi everyone. Yeah, great to be here. Really happy to be sharing a presentation about range and charge anxiety for EV drivers. So we'll start off with a little overview of some trends we're seeing in the EV space, and then an overview of what we've been working on in our EV solutions, so discovering chargers, range prediction and trip planning, and then also some new features as well. So electrification is happening all over, really widely, and we're seeing it in automotive. You might have heard that OEMs, car brands in the UK are being mandated to sell 100% electric vehicles by 2035 with a tiered approach towards that each year. We see in the commercial fleet sector, a lot of fleets are really trying to shift to EV to aid with their decarbonisation targets. And then urban mobility as well. You'll have seen the Lime bikes, the e-scooters, dotted around, sometimes all over the place. But all of this is representing a shift to more sustainable modes of mobility. But the EV experience in particular does have some setbacks. So we see broken chargers. It's not like a fuel station. You very rarely turn up to a petrol station and you can't fill up. But you do see that experience with charging stations. The plug types. There's a lot of options. They're not all compatible with all vehicles, and that's something that EV drivers really need to be aware of and have that information to be able to make those decisions. And busy stations as well. You know, it can take sort of 15 minutes, even at the really fast chargers, to top up on your journey. So the wait time, if a station's really busy, is longer and can really differ and set the EV charging experience apart from filling up at a fuel station. And on top of that, there's the variety in payment methods as well. So not all charging stations accept credit and debit cards. Often you have to download a specific app or use a charge card in order to pay for a charging session. And there's a big variety of those as well. So it can be fairly fragmented with the need to download a lot of apps and work out which one to use. So what are the concerns of EV drivers? If you're thinking about buying an EV, you might be worrying, are there reliable chargers nearby at home? I think around 40% of households in the UK won't even have the possibility of installing home charging. You might live in a flat or terraced house, and there's not an option of driveway charging, so you will have to rely on the public charging network. So you need to know what your options are. You want to know what your payment methods are, what options are available. And then when you're thinking about planning longer trips, how far can you travel with the remaining charge that you have? Should you plan on your journey, at your destination, charge beforehand, along the route? What's the most appropriate option for you? So Mapbox is addressing this with a sort of horizontal solution, sort of pulling together different areas of the Mapbox platform. So firstly, we've got charger discovery. So this is locating chargers within your given range, including the live availability status of the charging stations, but also driver preferences like preferred brands, cost of charging, and desired amenities. Range prediction, so this is taking context about a vehicle the current situation, the characteristics of the vehicle, and being able to accurately predict how far that vehicle can travel. And then trip planning, so taking a metagraph routing approach to including charging stations automatically into a trip plan. So you want to go from A to B, but which charging stations are the best ones to add into your route? And again, that can include specific preferences that a driver might have. And then underpinning all of this, high quality data regarding the charging stations. So starting off with charger discovery. The EV Charge Finder API, so this allows you to search for charging stations. This could be a radius search, viewport search, searching along a route, and then retrieving rich metadata about those charging stations. So this could be information specifically about a charging station, so the brand, the payment methods, but also things like the amenities that are available at the station or nearby. But then also nested within that, details about specific plugs within that station. So power, for instance, not all of the plugs at a charging station have the same power. You can't charge as quickly at all of the plugs. So that information is available at a plug level. And likewise with the compatibility and the plug type. But along with this, again, how EV differs from fuel stations is that the dynamic data element is really important. You really need to know what the status of the station will be when you arrive. So you can see here, is the plug available? How many of the plugs at the station are available? Is it occupied to like 4 out of 5, or is it 4 out of 20? And you can understand that actually I've got a good chance of it being available when I arrive. But then also, are there any plugs that are inoperative? Perhaps they've been taken offline, they could be broken, and you can understand that actually that's reducing the total plug capacity at that station. So bringing this into the routing experience. EV range prediction. So this is to help with range anxiety, giving EV drivers a precise range prediction on arrival. So with traditional routing from A to B, you're optimizing for distance and time to get fastest ETA. With an EV, you also need to consider the cost of the energy consumption as well. So you can see here, this is to predict the range on arrival and also the point at which the vehicle will run out of battery capacity. So to calculate this, it uses an energy consumption curve. So this is the rate at which a vehicle consumes energy at different speeds, and it's not linear. At lower speeds and also at higher speeds, the rate of consumption is higher. So when you see drivers on the motorway, the more they're speeding, the higher their rate of consumption is. Auxiliary consumption should be taken into account. So this is your heating, your aircon, other elements of the vehicle. That consumption also needs to be included. The maximum battery capacity, this is increasing more and more, we see with newer vehicles. And then elevation. So there's a lot of factors that influence the consumption, one of them being elevation. So what is the rate at which a vehicle consumes energy going uphill, but also what's the rate it recoups some energy when it's going downhill as well. And the initial state of charge. What's the starting point, and also taking into account here live traffic as well in the routing. So it's great to understand at what point you'll run out of charge, but obviously that's a situation most people are trying to avoid. So combining this with the EV charging station data, you can implement a trip planning experience. So you can see here, this means adding in charging stations to avoid running out of charge and to guarantee that you arrive with the desired state of charge. So often this is around 15%. At the charging station as well, you can then predict the charging time that's required at the station to arrive with a given state of charge. So you can see here that's charging from 30 to around 80%. And again, that's relying on a charging curve. So charging's not linear. You'll charge at a faster rate earlier on, but once you hit 80%, the rate of charging is much slower. It's actually similar to a phone battery. You need to take into account connector types when adding stations in. Is it compatible with the vehicle? The desired state of charge at destination, again, this can be around 15% to have a really efficient route, fastest time of arrival, less time charging. But actually, you might want to arrive with a much higher state of charge, adding in more stations so that you avoid having to charge, for instance, late at night on your way home, or maybe you're new to an EV and you just feel more comfortable having a bigger buffer. And then tailoring this to specific drivers, you can prefer specific charging brands, exclude certain operators for any reason, and prefer amenities as well. So that's sort of other POI data that's available nearby, so restaurants, restrooms. And then the charging strategy. Not everyone wants to optimize to arrive as fast as possible. You might prefer to take one longer stop and have lunch, but also the routing strategy could be optimized for taking stopping more often, but for less time. Maybe you want to break up your trip, take breaks, you've got your family in the car. So the route can be optimized for these different preferences and charging styles. So another feature to see how far you can go on a full charge is EV range map. So if you want to just quickly see on my current state of charge or on a given range of a vehicle, what does that look like? How far can I go? EV range map is using isochrone API from Mapbox. It's using the drivable distance in any direction based on that state of charge. Up to, I think, around 1,000 kilometers. And you can quickly see, like, can I make an intercity trip? If you're in a lower state of charge, you can then look and see what charging options you have available within your given range as well. So low range warning is using EV range map, but to proactively alert a driver that their state of charge is low, but then you can then give practical options of what you can do about that. So it's combining it with the EV station data. These are your reachable stations. You've got practical information there that you can action. So some new features in the EV space. The low range alert is an example of proactively notifying a driver when the circumstances of their trip are changing, either because of the vehicle or because of the factors along the route. There could be a change in traffic. As we saw with the range prediction, there are a lot of factors that influence the rate of consumption of a vehicle. And these can change along a route, although the prediction is really accurate. It's in most cases within a 3% tolerance. Driving styles do differ, and if for instance a driver's driving more aggressively, late braking, more acceleration, their rate of consumption will be higher. And you may find that actually a charging station then should be added into that route. You wouldn't necessarily want to automatically reroute a driver to a station, but you can use that to create alerts that can notify a driver, and then offer to add a station into their trip. Perhaps a better route's found because the the traffic conditions have changed, and then likewise the inverse of that would be possible as well. So if a driver is driving more conservatively, a stop may no longer be required. And then utilising the dynamic data and the real-time updates of the charging station occupancy levels, that can then be used to notify a driver if an upcoming station has become busy. So you can provide a notification for that, knowing if it's become occupied or if it's now closed or become out of order, can also change the behaviour. So you might opt to actually automatically reroute a driver away from a station if you know if it's closed or if it's been shut down, it's offline. But if it's become busy, this can be an option that the driver can choose to take or ignore. So yeah, how to get started. It's available, Mapbox for EV, in private preview that can be signed up for. But as I mentioned, it's also there's elements there of all of Mapbox platforms. So maps, search, and routing, all available at Mapbox. There's good free tiers and different ways to access. So yeah, please take a look, and thank you very much.
Thank you, Sophie. Who knew there were so many parameters in EV range? I thought you basically just put your foot down on the accelerator and the battery worked. We've got time for a couple of questions if anyone's got anything they'd like to ask.
Is this being targeted to end users, or is it an SDK that app developers can use in their apps, or is it being targeted directly at the OEMs, the car manufacturers?
The question was, is this being targeted at end users, or is it an SDK for the wider community there?
Good question. So at the moment we are working with OEMs, so it is being trialled in vehicles. At the moment it is in private preview, so you can sign up, but it's not possible to get public access right away right now. But it is supported in SDKs, but it's also available in APIs as well. So actually just requesting the charging station data would be available, and the routing API element as well.
Question here?
Yeah, presumably for getting things like the availability of charging places and out of order and so on, you've got a load of APIs you need to connect to from charging providers. Is that something you're having to do on a sort of one-by-one basis, contacting them, arranging deals, and doing that for chargers in the US and different charging networks in the UK and everything? Yeah.
The question was that obviously the system needs to connect to lots of different charging providers. Is that being done through lots of different APIs around lots of different companies?
Yeah, no, great question, and it is a challenge that's out there. We work with different data providers, but one of the actually really beneficial things is that the OCPI data standard has become quite commonplace in the market, and that has been adopted by a lot or most of the charge point operators. So that's used for sharing data and all of the metadata about a station and the real-time availability really consistently. And then for other use cases as well, it's also used for things like the charge cards, different payment options like plug and charge. It also supports that, and that's the same data standard that Mapbox is using as well for the data sharing.
On predicting the range, I imagine, but different manufacturers, different cars of different amounts of wear behave differently. Is it that complex, or can you just go, this is a car model, here's the battery capacity and volume capacity? How complex is that modelling you have to do?
The question was, when calculating the range, do you need to take into account the manufacturer of the car, or is it just a simple generic calculation?
It does It does depend on the make and model of the vehicle. You can see kind of, if you're in the market for an EV, when you're looking, there are kind of different, there are some data sets available that you can kind of infer some of that from. So you can use a kind of a standard set of details for a specific vehicle, for a specific make and model, and use that to predict the range. But likewise then, if you're actually setting up the range prediction in a vehicle, you can then have that update as well, so it improves over time. It could be sensitive to things like if the sensors say the weather's cold, you actually then say we'll have higher consumption, lower range today.
Is any of the software or data that goes into this available under an open license?
The question there was, is any of the software, the data that goes into this available under an open license?
The charging station data, I don't think so. It's essentially shared by the charge point operators. It is part of Mapbox's routing features, which are using Mapbox like roads data sets, and the data that's part of Mapbox platform does include open source providers. I think OpenStreetMap would be one of them.
Thank you very much, Sophie. That's all we've got time for in terms of questions. You can find her afterwards.